Hi, I'm Colin Elgie, Soil Fertility Specialist with OMAFA, based out of Ridgetown, and I'm here to talk today about tissue testing and soil sampling when it comes to nitrogen and kind of general nutrition in a corn crop. So the first thing we got to ask ourselves is, why are we tissue sampling? Why are we sampling the soil for nitrogen? And really it comes down to how you apply your nutrients, and whether or not you've got some issues that you're seeing in the field, or maybe you're just looking for a general kind of look at how that crop's doing and maybe some improvements that you could make. So when it comes to the why of what we're doing, we want to look at our crop and see, at this time of year, what does that look like? Are there anything that, any nutrients that we may be running short on? How's that general crop nutrition look? And specifically in this field we're at today, we've got some relatively short corn here. We've got a little bit of striping that we can see on some of these leaves. And then you might be able to see in the background there, we've got some tasseling. So the first thing we've got to think about is differences in the field. They could be any number of things. A lot of the time it could be nutrient related, but other times it could be something that may be related to our management, something like compaction, cold temperatures, planting depth, all that kind of stuff that management can really play an effect on. In this case, we're going to look at this as a nutrient issue and try and figure out what's going on. So next we'll take a look at how we actually sample in the field. So when it comes to tissue sampling, there's a few things that we've got to know. The first is, what stage is that plant at? So right here we can see that these plants are, count the leaves, we're at, say, V8. And when it comes to a plant in the vegetative stage, what we're looking for is really the top fully developed leaf. And so we can kind of look at this plant here. We've got some leaves that are still in the whorl, not fully out yet. And what we're looking for is basically that top leaf that's fully developed. And what we're going to do is snap that whole leaf off and stuff it in the bag. So when we're looking for the leaf to sample, what we want is the one that's highest on the plant, but fully emerged. So we've got leaves here that, even though it's starting to flop over, it's not fully yet out of the whorl. Not fully grown, not fully emerged, and so we're going to skip that one. This one, we can see that if we look down here, we've got a bit of a collar on the base of the leaf, and so that one is fully emerged now. So when we're sampling, we'd take that one, rip it off, and put it in the bag. And same with the next plant. So the collar that we're looking at really gives us an identification of whether that leaf's fully emerged. So we can see that the leaves above here, they're still wrapped up. We can't really see that collar. This leaf we can, and so this would be the top leaf that's fully developed. So this would be the one that we snap off and take a sample of. Going to go to our next plant, or a couple plants away. We're going to stuff that in the bag. Go on until you've got that bag filled up till it comes to the line. So every lab, they've got a different tissue sampling bag, and it's important that we pack enough plant tissue in here that they can actually use to analyze the sample. By the time it gets to the lab, a lot of that weight that's already there is water, and they dry it at the lab, so it shrinks down to almost nothing. And if there's not enough plant tissue in that bag, there's not enough to get an accurate sample from. So it's important to fill that up as much as possible, give a good sample, and really make sure that you're giving the lab something to work with. Another part that's critically important is when we come to a problem spot or something like that we're looking at, we want to take a sample, not in the very worst part of it, but kind of along the edge of where that problem spot is. And the way we do that is, or the reason we do that is so that we're getting that tissue as it's starting to be depleted. If we go to a plant that's already dead, that's really not going to tell us anything, because the nutrient levels are going to be completely out of whack. But we want that plant as it's kind of suffering, for lack of a better term. The other important aspect when we're doing a problem spot is that we want to take a comparison in a good spot. So we want another tissue test out of an area that is not affected by that deficiency to really give it a good comparison. So when we're sampling real young plants, it's a little bit different. What we want is really we want to take the whole above ground plant matter, and that's because there may not be enough leaf tissue to really get a good analysis out of. And so in this case, with a plant, this small, what we do is snap it right off at the base and take that sample. The only issue with this is, in this case, we've got some soil that has splashed up on the leaves from recent rains. And so when it comes to that, that soil can actually throw off the value of the analysis that we get from a tissue sample. So what we want to do with that is, bag up your samples, take them back, and give them just a quick rinse to wash that soil off. The other way is if it's dry enough, you can usually get a good enough job of brushing it off or ripping the very bottom leaves off. But it's important to get that soil washed off before sending it away to the lab to make sure that you're getting accurate results. So when it comes to corn that is at tasseling, near tasseling, and really silking, that's when we can kind of get a good picture of our general crop fertility. So you might have a field that you're not necessarily interested in looking at a problem spot versus a good spot, or you maybe are a bit late for nitrogen application. You're just kind of looking for a general indication of that crop's fertility. Silking is about the best time for that. We've got a lot of good data over the years in Ontario to really pinpoint kind of the general guidelines of where you should be in terms of that crop nutrition of essential nutrients. So when it comes to tissue sampling in that crop, what we're looking at is finding out, first of all, where that ear is. And we can see, obviously, with the silk here that this is going to be our main ear anyways. And so what we want to do is, instead of taking the top leaf, we want to take the ear leaf. So that's the leaf right at the base of the ear. And we want to take, actually, not the whole leaf, but the middle third. So you can kind of rip off the bottom third and the top third of the leaf, and that's kind of the sample you're left with. And so you want to go through a bunch of plants, take the middle third of the ear leaf, and that's what you'll send away to the lab. So looking at this plant, we've got our ear here in the middle, and we want the ear leaf, which is at the base of that ear. Snap it off. And what we're looking at is the middle third of that leaf. So we can take the bottom third and the top third, throw them away, and we're looking at the middle third to send away for sample analysis. Do that on a bunch of plants in a row or throughout the field, and that's a good way of looking at your crop nutrition at that time. So oftentimes when we're tissue sampling, whether we're looking at a problem spot or looking for a nitrogen analysis of that field, tissue sample is a great way to tell us what's actually gotten into that plant. But oftentimes we want to look at what's actually in that soil as well. And so they can differ. A lot of times we've got lots of nutrient that's in the soil, but there might be issues related to roots or uptake that prevent it from getting into the plant. And so that's why we often take a soil test at the same time. So if we're talking about a general nutrient problem issue, we'd take a regular 6-inch sample. We'd take it through that problem spot, again, get a comparison of a good area to really see the differences between there, pair them up with that tissue test to really show what's going on. When it comes to nitrogen, what we want to do is we want that deeper 12-inch or 30-centimeter soil sample. And so I've got a soil core here that is a full 30 centimeters. We want that depth because nitrogen moves. We know it moves with the water. We know it can leach out of the soil profile. And that 30 centimeter depth is critical to figure out what's actually in that rooting zone that we're looking for. It's important that you've got the right tools for the job. I've got a stainless steel soil probe here, and that's absolutely one of the best ways to really get that soil sample. What you want to avoid is any galvanized metal. So whether you've got a shovel, make sure it's a non-galvanized material, and especially the pail that you're putting it into, make sure that you're using a plastic pail. Any kind of galvanized metal that you're using at all can contaminate that soil and can throw that, especially the zinc levels, way out of whack. So it's one thing that often gets overlooked and can create issues when it comes to figuring out what's going on in that soil. And so it's important that we're using the right tools to make sure that that sample that we get is right and that analysis that we get is right. The key part when you're taking a soil sample for nitrate is you want to make sure you get that full 30 centimeter depth. And so you want your probe to be directly up and down. You don't want it on an angle like this, because then you're not going to get to that full depth. So it's important to take that and get that probe straight down and look at the sample. When you pull it out, you'll notice your depth of your core. And in this case, we're not quite at the marking for 30 centimeters. So in this case, we'd actually either go back in that same hole if you can keep that core intact, or take another sample to that full depth. It's important to take that full depth because that really lines up with what our recommendations are as far as nitrogen analysis. So when it comes time to take our samples and send them away, again, I want to stress that you've got enough in your bag, in your tissue sample bag, to make sure that the lab will have enough material to work with. It's critically important. You can do all the work of going through and sampling your field, and the lab doesn't have enough to show for it, so you don't get any results, or at worst, bad results. Same thing with a soil sample. You want to make sure you've got enough soil in there and that it's representative enough of your field, the area you're taking that in, to really get a good lab analysis. And so you want to take this soil, mix it around, make sure that it's well mixed, that you're getting a representative sample, and then bag it up and send it away. The number one most important, absolutely critical thing that you can ever do when it comes to tissue sampling or soil sampling is labeling the sample. If you send this away without any information on it and try to make any use of it, the lab is not going to know A, who it came from, B, where it's for, and C, what the heck is the point of it. So you want to make sure that you label it with something that makes sense to you and that the lab can figure out who it belongs to. So when we're talking in terms of using our tissue sample or our soil nitrate sample, it really depends on that time that you take that sample and what you're looking to do with it. So with tissue sampling, it's important to remember that that tissue is a snapshot in time. It's absolutely what is in that plant at any given moment, depending on when you take the sample. And so that can give you an indication of whether you're maybe high or low in nutrients, and maybe a bit of an indication on what you should do there. When it comes to nitrogen and making a recommendation, tissue sampling is a tool, but it's hard to make a real recommendation with that analysis. The one thing that can be done is if we've got optimal growing conditions, we might be able to tell, well, maybe we should have applied a little bit more, or we've got enough nitrogen there, we could have got away a little bit less, but it's hard to really fine tune from a tissue sample by itself. And that's where that soil sample, that soil nitrate sample becomes so critically important. When we've got that 30 centimeter depth at that right time of year, again, it's a snapshot in time, tells us what's in the soil at that time, but that's where we can actually use those analysis numbers to make a recommendation. OMAFA's got published guidelines in our agronomy guide, publication 811, that show During that pre-side dress timing, what kind of a nitrate part per million rating can lead to an actual pound per acre recommendation. It's important that if we're using that nitrate analysis for the recommendation, that there's a few guidelines we've got to adhere to. So if you've got less than 30 pounds of nitrogen on in form of a starter, no manure applied, no real cover crop that we're looking for a nitrogen credit from, that's where that analysis really is calibrated for. By the time we add any of those different factors in, if we've got 100 pounds of nitrogen up front, if we've got manure in the field operation, if we've got a red clover cover crop that we're trying to credit, it gets a little more complicated and we can't use those recommendations. What that nitrate sample is still useful for is looking at it on a comparative basis, either field by field, or the real benefit is on a year-to-year basis. So if you've got the same management program over the same fields year after year after year, you can compare those nitrate samples. Say your long-term average is 22 part per million using your program, and this year's comes back at 15 part per million. Well, you can maybe say that there's less of that soil supply. We should be bumping up our rate a little bit to compensate for that. It's really that comparative aspect that gets a lot of benefit out of that soil nitrate test.